Okay, let's talk about some of the systems of DE homework problems. So I set up this homework assignment a few months ago, right before class started, and I was looking through it today, and I was like, "Wow, I'm really going to have to think about how to solve number one." I thought there was a video here to help you with it, but there's not. So I've spent the last 10 minutes trying to figure it out myself. So I figured, yeah, you're probably going to have trouble with it. Let's talk about it. I did figure it out, of course. So now pause the video, read the question, make sure you understand at least what X and Y are. So X is the amount of salt in tank A at any given time. These are both functions of time. Y is the salt in B. So I'm going to write some stuff down here to help me as much as you. So X is gram, I think it's in grams. Grams of salt. In tank A. Y is grams of salt in tank B. So dx dt will be measured in grams per minute. That's our key. We got to think about units here. This whole problem comes down to unit conversion. I want to know how quickly salt is entering and leaving tanks A and B per minute in grams per minute. Okay, so dx dt, everything that's coming into X, all the salt that's coming into X. So a solution of 4 grams per liter at a rate of 5 liters per minute. One of the first application problems we did was just like this. It was like the first group assignment. So grams per liter, that's not what I want. I want grams per minute. So that's how concentrated the stuff flowing into A is. This is how quickly it's coming in, 5 liters per minute. So let's over here, this is into A. And I literally forgot what the numbers were, 4 and 5. 4 grams per liter at a rate of 5 liters per minute. If I multiply those together, that's liters cancel, 20 grams per minute. That's flowing into A. Okay, so that's already in the right units, grams per minute. X is changing by 20 grams per minute. It's not multiplied by anything, it's just a constant, a number. Same thing's going to happen over here with tank B. Five grams per liter, 7 liters per minute. So into B, 5 grams per liter times 7 liters per minute is 35 grams per minute. So Y is going to be increasing at a rate of 35 per minute, 35 grams per minute. Okay, now we start mixing these tanks. So 8 liters per minute is going to flow from A to B. I need to convert that over into how much salt is going from A to B. Okay, so we started with 50 grams of salt in A. So X of 0 is 50 grams. So at time t, the concentration, the amount of salt per liter, concentration, spelled concentration wrong, concentration in A will be X divided by 50. I got to think about this for a second. Oh, okay. Yeah, I had the right number, but I used the wrong thing because that's not grams per liter. So this is true. That's not what I care about. So initially, 50 liters of water NA. Who cares how much salt was in there? There were 50 liters of water. So my initial concentration was 1 gram per liter, right? 50 over 50. That was my initial concentration. At time t, my new concentration will be the amount of salt in there divided by the amount of water that we started with. So that's grams per liter. Because this is changing. The amount of salt is changing divided by the total amount of water. Okay, but the water's changing. We are flowing 8 liters per minute from A to B. So dx dt is going to be changing by minus 8 times that thing I just had there. So this will be the current concentration. Oh, but we're losing 8 liters of water per minute. So that was in liters per minute times grams per liter. The liters cancel. This whole term here is in grams per minute. Well, if that's leaving A, that's going to be going into B. So because I wrote that as a minus here, we're going to have a plus, the same thing over here. Because that whatever's leaving A was going into B. We get the same game here. 3 liters per minute going from B back into A. Okay, so Y of 0, I'm kind of answering questions out of order here, was 60 grams. With 40 liters of water, or 40 liters of fluid total. So then at time t, the concentration will be the amount I have in there, the amount of salt, divided by that 40 liters we started with. But that amount is changing by 3 liters per minute. So I'm going to be losing minus 3 times that fraction, y over 40. Well, where is that going to? That's going back into A. Plus, we're also just draining 11 liters out of B. It's not going back into A. So we're also going to have another minus 12 y's over 40s that are just leaving B, but we're not going to put up here plus back into A because it's not flowing into A, it's just being drained out. Okay, so you can see here where everything came from. They combined that together when they coded it. And then our initial amounts are the initial amount of salt, not the initial amount of water. Okay, so you're going to have the same problem with different numbers. Hopefully that will get you through. I had to really think about this one. I honestly had to look at their answer and kind of, backwards figure it out. Okay, now I'll show the answers. Let's actually do one from start to finish, actually solve a system of DEs. So I've got dx dt is negative 2x minus 2y. And dy dt is negative 2x plus y. It's plus y, I think. Yep. Okay, so we're going to write this in matrix form. My matrix A will be negative 2, negative 2, negative 2, 1. And this dE is the vector x prime equals A times the vector x, where the vector x, capital X, is a vector made up of little x and y. Okay, we want to find the eigenvalues of this matrix. I'll go into full screen here. Okay, so we want the determinant of A minus lambda I to equal 0. So that will be negative 2 minus lambda, negative 2, negative 2, 1. That determinant will be 0. So we do this little cross multiplying game this way minus that way. I left off my minus lambda here. Minus lambda along the main diagonal. So that guy and that guy, you put a minus lambda after. So going this way, negative 2 minus lambda times 1 minus lambda minus this way. Negative 2 times negative 2 would be 4. And that's supposed to equal 0. FOIL, so I've got to be careful here. Negative 2 plus 2 lambda minus a lambda plus lambda squared minus 4 equals 0. So putting this in standard form, lambda squared plus lambda minus 6 equals 0. I can check the answer and see if that, I just don't want to get all the way through. Negative 3 and 2 is what we should get. That's lambda plus 3. Yep. The minus 2 equals 0. So we get two answers, negative 3 and 2. These are my eigenvalues. Okay, now I got to find my eigenvectors. Now remember, there are two different ways to find eigenvectors. So let's do lambda equals 2 first. So I can do A times some vector k equals lambda k. Or A minus lambda I times k equals 0, the 0 vector. Either way works. This one has more work at the beginning, but then you're solving it is easier because you have zeros in. This way has less work at the beginning, but more work at the end. I prefer the second way. So lambda equals 2. I'm looking at this matrix right here and I'm plugging in lambda equals 2. A minus lambda I. That matrix will be negative 2 minus 2. Negative 2, 1 minus 2. I'm just plugging in 2 there for my lambdas. So that would be negative 4, negative 2, negative 2, negative 1. Supposed to take that times my vector k, k1, k2, and that should equal the vector 0, 0. Now, we're going to get a system of equations here that is a dependent system. We're going to get the same equation twice. If you don't get the same equation twice, you've done goofed. Eigenvectors are not fully determined. The direction is determined. The magnitude is up to us. You're never going to get a unique solution for an eigenvector because any multiple of an eigenvector is another eigenvector. So we just multiply through here. Remember how to multiply vectors, row on top of column. Negative 4k1 minus 2k2 equals 0. The other equation, if I do the bottom, would be negative 2k1 minus k2 equals 0. These are literally the same equation. If I take this guy times 2, I get this one. So I solve either one of these. It doesn't matter. I'm going to solve the second one because the numbers are easier. So I'm going to move that k2 over. So this is just a relationship. When it comes to eigenvectors, all we're trying to find is a relationship between these two. So now I want any vector that satisfies this equality. I can make up numbers. I could, if I wanted to, say k1 equals 17, so then k2 would be negative 34. Works perfectly fine. You make up anything you want. I like to just swap coefficients. So that guy's coefficient right there, I'm going to name him. And this guy's coefficient, that's a 1, I'm going to name him. Then I don't have to do any thinking. So this guy is 1, this guy will be negative 2. So that vector will be the vector 1, negative 2. I could, it's literally any multiple of this works. So I could have put the negative there and the positive there. Negative 1 and 2 works just as well. Okay, so that's my first eigenvector. That's for the eigenvalue lambda equals 2. Okay, now we do our other eigenvector. So lambda was negative 3. I have to look at my matrix again. So we're going to take just this row here and subtract 3 along the main diagonal. So I'm going to write this again. A minus lambda I times the vector k should equal the vector 0. So this, I should just copy and paste A. Negative 2, negative 2, negative 2, 1. So here it's going to be minus negative 3 along the main diagonal. That's plus 3, minus a negative 3 times the vector k. Now, I remember when I took this class, I struggled a lot with, well, I've already used up the symbols K1 and K2. Should I call these K3 and K4? Because we really shouldn't reuse symbols. Don't stress about that at all. Like, I've already finished this first eigenvector there. I'm done with it. I'm never going to come back and refer to this again. I've got this written here. I don't need to come back and refer to this ever again. It's okay to reuse symbols again. So I'm going to, again, call these K1 and K2. If you don't like doing that and you want to call it 3 and 4 or A and B or whatever you want, that's up to you, but it's not necessary. And this should equal 0, 0. So what do we get here? I think that's 1, negative 2, negative 2, 4 times the vector K1, K2 equals the vector 0, 0. So multiply across the top, 1K1 minus 2K2 equals 0. And I'll go ahead and write out the second one just so we can look at it. Negative 2k1 plus 4k2 equals 0. These should be the same equation. If I take this guy times negative 2, I get this one. Okay, so move this guy over. 1k1 equals 2k2. And then my suggestion to you here, just swap the coefficients. So say k1 equals 2, k2 equals 1. Then just look here, 1 times 2 is 2 times 1. So this vector would be the vector 2, 1. And this was for the eigenvalue. Each eigenvalue gets an eigenvector. Okay, then our solution is going to be C1 e to the lambda 1. Doesn't matter which one you call lambda 1 or lambda 2. What matters, though, is that you put that guy's eigenvector. These go together. And then the next e to the next lambda, and then his eigenvector. So our solution is a vector, not just one single function. So in this case, that would be C1 e to the 2t. Oh, I forgot my t's. Sorry. Our independent variable is almost always going to be t in these. What was that first eigenvector? 1, negative 2. E to the negative 3t, 2, 1. Okay, so this is a vector. Remember, x here is xy. So x of t, little x, that's a capital X there. Meaning all of my functions in vector, put into a column vector, these were x, y, z, whatever, however many we have. What we called x is the top. So go all along the tops here. C1 e to the 2t times 1 plus C2 e to the negative 3t times 2. I'm just going all along the top. Okay, now that looks weird writing it like that. So I would probably just put that 2 here. I should erase the 2 there. Okay, and then y of t, we go all along the bottom. So again, I'm going to put the coefficients in front. Negative 2 C1 e to the 2t plus 1 C2 e to the negative 3t. Now, I know this confused me when I first learned this. What isn't 2 times C2 just another constant of integration? Do I really need to? No, you can't do that. Our coefficients, our arbitrary constants here were already set at this point. So when I put the C1 and the C2, those are stuck forever. Because this is now a system of equations. See, I've got a C2 in both of them. So when I solve an initial value problem, I have to solve a system of equations. So you can't play any kind of game like, oh, well, 2C2 is just C3. No, don't introduce more. Okay, so here's my general solution. And that can't be simplified at all. Okay, but this was an IVP. I want to solve x of 0 is 0 and y of 0 is 1. So I'm solving for C1 and C2. X of 0 plug in 0 for all the t's. E to anything, e to 0 is 1. So we'll get C1 plus C2, and that's supposed to equal 0. Y of 0 would be negative 2C1. E to the 0 is 1. I'm not taking any derivatives here. These aren't x prime and y prime. They're just x and y. That's supposed to equal 1. So now I got to solve this system of equations. And I can do that using substitution, elimination. You get my calculator out. Like, we've already done a lot of work on a test. Like, this is all one problem here. Well, I guess that was the other problem up there, right? Yeah, okay. But from here down, it's all one problem. I honestly, if you handed this to me, I'm just going to solve this by substitution. But if you want to just type this into Wolfram Alpha and get the answer, or use your calculator or whatever, that's totally up to you. Just on the test, write me a little note here and say how you solve the system. I want you to get here and write this down, but I don't have to see your algebra working it. I'm just going to go ahead and do the algebra here and say C1 is negative 2C2. Take that, plug it there. So that'd be what? 4C1 plus C2 equals 1. C2. Yeah. 5C2 equals 1. C2 is 1/5 or 0.2. Let's see if I got that right before I go. They got 0.4. I did something wrong. Oh, no, we're okay. We're okay. That's right. Let's see. It's supposed to be, no, what did I get? C2. Oh, yeah. Okay. Look right there. There's that 2. 2 times C2. So we will get a 0.4 there. Okay. I just want to make sure before I spend the next 5 minutes finishing this up, I want to make sure I did it right. All right, now we plug that we just got back in here. So C1 plus twice 0.2 equals 0. C1 is negative 0.4. So x of t is C1 e to the 2t negative 0.4 e to the 2t plus twice C2. Don't forget about these guys. 2 times C2 would be 0.4 e to the negative 3t. And y of t, same game. Negative 2C1. So negative 0.8, no, positive 0.8 e to the 2t plus C2 0.2 e to the negative 3t. Let's see if I did all that. Yep. Yeah, so they wrote it in the other order. That's okay. Okay, so these are long problems. Okay, this one here is converting a second order into a system of first order. Make sure you watch that video. I don't want to do this one for you. I want you to try this one on your own. And then these are similar. Oh, the fact that you're getting cosines and sines here tells me that you're getting complex eigenvalues here. So make sure you watch that video. Okay, that's a good place to stop.